Have you ever wondered how scientists discover and identify new elements? This question opens up a world of curiosity, a world filled with the smallest building blocks of matter that we know, elements. These elements, from the oxygen we breathe to the silicon in our computer chips, play a vital role in our everyday life. Yet, how much do we really know about them? How are they discovered? Who are the masterminds behind their identification? Picture a group of scientists, tirelessly working in their labs, peering into the essence of matter, seeking answers to questions that boggle the mind. Their mission is not just to uncover the secrets of the universe, but to stretch the boundaries of our knowledge, to identify new elements that can revolutionize our understanding of the world around us. Our journey into the intriguing world of element discovery is just beginning, so buckle up and dive into this fascinating world of element discovery with us. The first step to discovering new elements often begins with a prediction. Now you're probably wondering, how do scientists predict an element that doesn't exist yet? Well, it's all about understanding the patterns in the periodic table and the principles of quantum physics. You see, the periodic table isn't just a colorful poster in your chemistry classroom, it's a powerful tool that guides scientists in predicting the existence of new elements. Elements in the same group, that is, the same column in the periodic table, have similar properties. By studying these patterns, scientists can anticipate the properties of yet-to-be-discovered elements. But the periodic table isn't the only tool scientists use. Quantum physics, the study of the tiniest particles in the universe, also plays a crucial role. Quantum theory describes how these tiny particles behave, and it allows scientists to predict the atomic structure of potential new elements. So, how does this work in practice? Well, imagine you're a scientist studying the elements in group 17, the halogens. You notice that these elements have 7 electrons in their outermost shell. You also notice that as you go down the group, the atomic number, which is the number of protons in an atom, increases. Following this pattern, you could predict the existence of a new halogen with an atomic number higher than those currently known. But predictions are only the first step. Scientists use these predictions to form hypotheses. These hypotheses are then tested in the lab, where scientists try to create the predicted elements. They do this by bombarding target elements with high-speed particles, hoping to create an atom with the predicted number of protons. So, you see, theoretical predictions are more than educated guesses. They are the foundation of discovering new elements, grounded in the established principles of the periodic table and quantum physics. Once scientists have a theory, it's time to put it into practice. And that's where the real fun begins, in the synthesis of new elements. But that's a story for another time. For now, let's appreciate the beauty of the theoretical predictions that guide scientists in their quest to expand our understanding of the universe. The next step is to create these predicted elements. Now that we've got our theoretical predictions sorted, it's time to put on our lab coats and goggles. You see, turning these predictions into reality is no small feat. It requires a blend of advanced technology and scientific ingenuity. One way scientists go about this is through nuclear reactions. These reactions involve bombarding a target element with various particles. Picture a microscopic game of billiards where scientists shoot particles at the target element hoping to strike gold, or in this case, a new element. But it's not as simple as it sounds. The process requires an incredible amount of energy and precision. Particle accelerators, also known as atom smashers, are another tool scientists use to create new elements. These machines accelerate particles to nearly the speed of light before smashing them together. The resulting chaos can sometimes form new heavier elements. Now I can hear you asking, why can't we just make all the elements this way? Well, the challenges are numerous. First, these experiments are incredibly hard to set up and carry out. They require state-of-the-art facilities and a team of brilliant scientists. Second, the elements we create this way are often highly unstable. They can decay into lighter elements in a fraction of a second. This makes them very hard to detect and study. Finally, the process is not always successful. Sometimes, despite our best efforts, the particles just don't combine to form a new element. Despite these challenges, the rewards are immense. Each new element we create deepens our understanding of the universe and opens up new possibilities for technological innovation. So, creating new elements is a complex and challenging process, but it's also an essential part of our quest to understand the universe. The next step in this journey? Confirming that what we've created is indeed a new element, and not just a result of wishful thinking or a faulty detector. After the creation comes the confirmation. Identifying a new element is a meticulous process. Just as a detective uses clues to solve a mystery, scientists use indicators to identify new elements. They are the detectives of the atomic world, if you will. The first step in this scientific investigation is determining the atomic number of the suspected new element. The atomic number is the number of protons in an atom's nucleus, and it's the unique signature of each element. It's like the fingerprint of an element. No two are the same. When scientists suspect they've created a new element, they must prove it has an atomic number different from any known elements. But how do scientists count the number of protons in an atom's nucleus? They don't have microscopic rulers after all. This is where detectors come into play. These devices, often referred to as particle detectors, can record and interpret the high-speed collisions of atomic particles. They can measure the energy and momentum of these particles, providing clues about their origins and identities. One of the most widely used detectors is the alpha particle spectrometer. It's like the bloodhound of the atomic world. It sniffs out alpha particles, clusters of 2 protons and 2 neutrons, that are emitted as a new element decays. By measuring the energy of these particles, scientists can infer the identity of their parent atom. Sophisticated technology also plays a crucial role in identifying new elements. High-speed cameras can capture the fleeting moments of atomic collisions, while supercomputers crunch the data from these experiments. These tools offer scientists a glimpse into the atomic world, allowing them to identify new elements with unprecedented precision. However, identifying a new element is not like finding a needle in a haystack. It's more like finding a specific grain of sand on a vast beach. It requires patience, perseverance, and a keen eye for detail. Scientists often have to sift through mountains of data, analyzing countless atomic collisions before they can confidently claim the discovery of a new element. But the process doesn't end with identification. The discovery of a new element is just the beginning. The real work begins when scientists start exploring its properties and potential applications. But that's a story for another time. For now, let's marvel at the scientific wizardry that allows us to expand our understanding of the atomic world. Once an element is confirmed, it needs a name. The process of naming new elements is a significant one, governed by guidelines from the International Union of Pure and Applied Chemistry, or IUPAC. The rules state that elements can be named after a mythological concept, a mineral, a place or country, a property, or a scientist. Often, new elements are named to honor the scientist who discovered them or places that have contributed significantly to scientific research. Take Einsteinium, for instance, named after the brilliant physicist Albert Einstein, or Californium, which pays tribute to the state of California where it was first synthesized. The naming process is a celebration of scientific achievement, and it's a chance to stamp a new discovery with a meaningful and memorable moniker. This tradition not only honors the past, but also inspires future scientists to make their mark on the periodic table. Every new element brings us one step closer to understanding our universe. So, why do these new elements matter, you may ask? Well, the discovery of new elements is not just about adding more squares to the periodic table. It's about expanding our understanding of the universe and unlocking new possibilities. Each new element we discover holds potential applications that could change our world. Imagine new medical treatments, revolutionizing our approach to disease. Picture advanced technology, making our devices faster, more efficient, and more sustainable. It's like finding new colors to paint with, opening up a whole spectrum of opportunities we haven't even dreamed of yet. And yes, it's a difficult and time-consuming process, but it's this very quest, this relentless pursuit of knowledge that drives us forward. The quest for new elements is a testament to human curiosity and ingenuity. It's a reminder that no matter how much we know, there's always more to discover, to learn, and to understand.